Earthquake-resistant building design by Birkamo Puggle. Background information. Imagine the ground beneath your feet suddenly began to shift and shake as buildings tremble and cracks emerge. This phenomenon is known as an earthquake. It is caused by the movement of tectonic plates that generate seismic waves, vibrations which transmit energy from within the earth. The 2023 Turkey-Syria earthquakes were one such series of deadly earthquakes that occurred during our recent times. The casualties resulted in 62,000 deaths and 122,000 injuries. The estimated damage was said to cost around $163.6 billion. The problem statement. The city of Lausanne is located along a major fault line and experiences frequent and moderate to strong earthquakes. So as a result, an affordable and earthquake-resistant design needs to be commissioned. Their design must be capable of protecting its occupants, minimize damage, and consider material costs and construction time. So here are the design materials and considerations. So the end result was that it must have a 8 by 8 centimeter base and it must be around 30 centimeters in height. The idea. In order to formulate a design that is earthquake resistant, it must touch upon certain factors. So these factors being strength, stability, and efficiency. And attached is the photo of the blueprint of what the structure would look like. Characteristic number one. A damping device refers to a system which absorbs seismic waves created by earthquakes. As a result, the structural integrity is safeguarded, as structural damage is minimized and occupants are protected from severe injuries. So, in order to incorporate a damping device into my design, I had to purchase an additional cardboard base. Afterwards, a felt which acted as a shock absorber was sandwiched between the two cardboard bases. Since the damping device was located at the base will remain stable and it will provide additional resistance against the seismic waves. Characteristic number two. Diaphragm refers to a structural element which consists of a surface, which transmits horizontal forces that are produced by earthquakes into vertical structural elements such as beams or columns. The diaphragm acts as a force distributor, which ensures that the forces are distributed evenly throughout the building. In order to create a strong diaphragm for my design, I had to use four popsicle sticks and they were strapped to the base with the remaining felt. The structural system will prevent structural failure by restricting any part of the structure to move independently. If any part were to move, it could potentially lead to the collapse of the entire structure. Characteristic number three. So a type of bracing that is well suited for earthquake resistant structure is the K bracing. So it is a variant of the diagonal bracing. K bracing is arranged in a pattern that resembles the letter K, hence that's where it gets its name from. The K braces enhances the overall load bearing capacity, which ensures that it withstands any forces that attempt to laterally push or pull the structure. As opposed to another bracing method, K bracing provides a lightweight and effective reinforcement without requiring excess amount of materials, therefore saving both time and resources. Tests and feedback. When the structure was being built, various earthquake simulations were conducted with fellow engineering students. The design of the structure was pitched to the judges, all of whom hailed from an engineering background. The, the design was praised for its effort in preserving structural integrity while being resource efficient. When the structure was to be tested on an earthquake simulator, small logs were hung throughout the structure, which signified the load. And then out of the 25 groups that pitched their ideas, my design ranked in top 5 because of how long the structure remained stable during the simulations. Aftermath. At the end of the day, building structures is not all about what designs or materials are used, but also about security. The blueprint that I developed offers more than structural stability. It offers a sense of hope and security for when the unexpected occurs. As an engineering student, I strive to abide by the engineering code of conduct to ensure the safety and well being of others, especially to those who are in need. Imagine living in a city like Lausanne, which experiences high seismic activity. The idea of your home and everything you hold dear collapsing is a terrifying thought. However, I aim to turn that fearness into reassurance. Every detail about the design of my structure offers a strong safeguard for its occupants. Each thorough element implemented in the design is capable of enduring the challenges posed by earthquakes. Here the works cited, and thank you for listening to my pitch.